Welcome back, guys. So today, what are we gonna do? Let's just check the to-do and bring back our context. What is it? Check why our processing is working. So I believe last week we managed to get the IRQ working. And right now IRQs are working and the L3 page table entries are working. Now I guess we just have to manage to get the what the fuck is this? We just have to manage to we just have to manage the what is it? Switching, the actual switching. So right now we have two processes and two user processes, and they need to be switched. And when we actually switch something, we are getting an fault. Let's try to see that in action first of all. Let's just run it out of IQ handler, and if we and we have an error at do we have a better error? Yeah, this is the first error, and it says for 102. When we try to access this memory, we got level 2 page table entry error. Okay, so how do we even get started? Currently we don't even have two processes initialized. We have commented everything out. Then what exactly am I expecting to run here? Okay, that is just to go into a IRQ handler and come back to normal this execution. Even that is failing currently. So that is what we want to fix first of all. IRQ 2 kernel code switch is already is fucked. Okay, so let's see. Okay, what exactly does it mean to switch something? Let's see. We have the handler that is going to say that IRQ is print and it's breaking. And what about the context? Only if it's an actual scheduler, we are gonna do that extra step. Right now we don't have a scheduler. Right now let's just first of all get into IRQ handler and switch back to normal kernel context. So let that be as it is. Okay, what about okay, now let's check our actual handler. I believe this is it. So we save something, we move that to the first argument, we call the function, we move the output of that into SP. Okay, so it has to return a context. Are we returning a context? No. IRQ is not returning any context, but it is using a context. But then it's an address, so maybe we don't have to what will be in the top of the stack, or we can just let's just return that. It would be the easiest way, so we don't have to worry about anything. Now we should have that in there. Okay, let's see. Oh, okay, fuck me. I have to change the context. Oh, just that context star. So it's always going to return a context star, and I don't think we have to update the signature. We can just keep it as it is. Let's just run it. Okay, now it's working. We are able to switch between contexts because we have a timer interrupt, and then we out of the handler, and again the timer interrupt is handled. We can also check if things are working inside kernel level. All we have to do is we go into this, and let's just copy this, and let's get into this and put a paste here. This is what we should never reach this code, but let's just simply, because there's nothing else here, so we'll put it here. What the fuck? The kernel never seems to be running. Is it because there's just too much we are always getting interrupted and the kernel does not run at all? Doesn't look that way. Because we never reached this code. As soon as this happens, we haven't even printed this yet. So what can we do? We have to remove some print messages so that the interrupt handler will be lightweight. Okay, let's remove this. Let's remove this. We haven't done anything. Let's see if the kernel at least reaches that point. Nope. Does not seem to be happening. Okay, well, let's just do one more thing then. Let's just go to R. Wait. First of all, there's one more thing that we could do instead. Instead of giving FF here, that would mean it's just accepting every damn interrupt. I don't know if it will make any difference. You can also give F0 there. So it will only prioritize certain things. Let's see if it makes any difference. Okay, it did not make any difference. Okay, then what can we do? What we can do is yeah, we can minimize the amount of time that we wait for an interrupt. Maybe we can do that. How do we do that? We go into timer.c. What if we increase that? Nothing happens. And you can reduce it by reducing 1 0. Okay, now it's running. Okay, then we'll reduce it even further. So it was just being constantly bombarded by IRQs. So there was no time to even run. Right now the kernel is running. Now let's see. I fucking VS Code just does not like something happened here. My scroll button does not seem to be working. It's automatically moving somewhere. Okay, whatever. Let's just bring back those two print messages so we know what is happening here. Okay, as soon as the IRQ starts firing, nothing happens. We don't seem to be coming back. We got in context and we figured that it's a time interrupt and we went back, but why are we still inside the IIQ handler? Okay. I think what we have to do is that sample it and based on that throw the interrupts. I guess that's how we should be doing it. No. We get interrupted at some point and then we move from that interrupt handler context back to where? Did we come back to the kernel context at all? I have doubts regarding that. Okay, then let's bring back all of this shit, because we need to use some CPU cycles. Only then we can actually tell if we can switch. Okay, now we have 2 tasks scheduled, so we should never reach this code. We will be getting into this, and that is it. Redefinition of A. Why did I define it first? Oh, I have defined it here. What the fuck? Let's run it again. Task 1 is scheduled, and we get the IRQ handler fired. And now we also have to do one more thing, that is to schedule this context. No. Scheduled. Task 1 is scheduled, and we are just keep on we are always inside IRQ dispatcher. Maybe, just maybe, this context, I have to confirm this return address. When we came inside, we are supposed to have an return address. And what is that return address? It should be ELR EL1. Let's see. Context ELR EL1. Okay, this is the address. This is always this address. Okay, let's just get this decimal to hex. And this is the address. Let's see what's in there. This is example. Oh, fucking oh. Okay. Let's just put xi star 0x. Okay. Right now there's no that's okay. I get it. Disassemble. No, but I should be able to access this. 1, 2, 3, 4. It's kmain 420. What is kmain 420? Disassemble kmain. Was that? So the return address seems to be fine because looks like the return address is pointing to, as soon as this comes in, it is pointing to somewhere to this, and the first user address seems to be here. Maybe, just maybe, let's just move to here. What the fuck happens? I have to kill this. How do I have to put exit? Okay, I guess I'll put W X. I think I have to kill this fucking thing, or it will just going to fuck with me. Oh shit. Now to delete that commute log. Once I ran it like this, I guess I forgot to kill it, and this log file was around 500 GB. This is a fucking camo. Let's check it. Du, right? Du.h. Camo log camo 1.log. See, it's already 6.3 GB. Okay, let's fuck it. No, let's just enter into timex. Okay, fuck. Then I tmax charge. Oh, it's still running. That's even more annoying. How do I kill this session? Shit. Desktop kernel simple kernel new tmax new still there? Fuck me. Tmux list sessions. Tmux how to kill a session. Kill. Come on. Wait. We just have to kill a current window. I put... okay. Let me try that. Attach. And... yes. Okay. We fucking killed it. Let's just create a new one. Name it as is it Kernel? I just don't remember things sometimes. Simple menu, and let's remove that chemo log file. My entire VS Code will slow down if I have this file there. Because it's being loaded inside the actual window, so it just simply does not like to work. Okay, looks better. Okay, what I was trying to do here, I have moved it. Now I just have to run it. Bash build. Okay, looks like we did not as soon as the first one is scheduled, we get a timer interrupt, and we always get the timer interrupt. What is this? I mean, it's fine that we always get the interrupt. I just don't understand why. Why would it? We have this. We save it. We get into IQ handler. We return. And when we return, are we getting a scheduled error even before that? Maybe we can just bring back the old timers. I hate it when my fucking VS Code does some random scrolling. As soon as the first one is scheduled, we are always in that. And what is that line? xi 0x, and now it's again that 420. And what's in 420? December. Okay, still we did not manage to get here. We're simply gonna return the context that was already there, and then when the next. But my question is, shouldn't there be a little bit of time just after we return the context and the next timer gets fired? There should be at least few clock cycles. We should have progressed a little bit, at least few instructions. What if we just let it run? The written address did not get updated at all. And if we do this, we just get this fucking thing. And then we have to kill the entire thing. Okay. I don't know. Sometimes I have to also be worried whether my recording is working at all. I'm wondering if this does it. It also sets the same. We don't have to acknowledge that IAR because we would always. And we are returning that context. The address is exactly the same. Okay. What else can we think about? First of all, I have some questions like how come let's just write it down and we can think about it. How come there's no cycles just after we return from the timer interrupt plus, that is like, let's see, we have a timer interrupt, and then we handle it. Let's say this happens at 10 ms, and we handle it, let's say, at 14 ms, and then we gotten back to kernel code at 17 ms. Then we should have be running next instruction for 3 milliseconds, right? Only after that next timer interrupt will come at 20 milliseconds. This should be the actual flow. But how come I'm getting it, I'm handling it, I'm getting back, but as soon as I get back, there is another timeout. That just does not make any sense. There should be at least few milliseconds there. That's why we have to increase this timer interrupt value. But I don't know, it does not seem to increase at all. I hate the fuck out of it. Why the fuck are you not moving? Oh shit. Fuck. Okay, this fucking thing is... Okay, is it working now? Okay, it's a lot better. It's so fucking annoying. Current frequency, where is this current frequency value? What the fuck? Nobody defined this fucking thing? This is just so fucking shitty. This variable is not even defined. What the fuck am I thinking? What the fuck is this? Okay, but at least in this case, when a timer's interrupt occurs, I wait for 1000 and only after that I set this. I mean, like only at 10 after 100 I actually set print this. That's why maybe it felt like it worked. Okay. Now it makes sense. No, let's just put a big value there. still it did not work. Okay, that seems like a big value. What the fuck? Even 1,000. Okay. I'm reading the frequency here, and it's being stored inside this value. And then I set it so it did have a value. Okay. Again. So I read it inside this, and then I set it, that is frequency divided by 10. Shit. If I give 10, it does not seem to work. Okay, then we'll just give a even bigger value. Did not seem to be changing any damn thing. It's still getting fired at the same rate. I don't know. I'm just thinking what could have gone wrong. Let's just get my assumptions straight. We are inside EL1 IRQ entry. Maybe let's just limit this to EL1 sync entry. Restore any reds. Okay. No idea. No freaking clue. So what we can do? What can we do actually? We set that. What exactly does it mean to set it? What if we don't set anything? If we don't set anything, who will refire the same con? I think we have to enable it again, right? Something like that. Even without anything, it still is getting refired. How is that possible? So something is wrong. Something else is wrong. I don't think this is the issue because from what I remember, if the timer interrupt comes, we have to re-enable it. Only if we set it again, it will fire. I think so. I don't think it would on its own fire the same interrupt again because we have to re-enable it, which we do inside the schedule next task. There's this schedule on tick, but because when we come here, when we try to return something, before that we enable the timer interrupt and we return. Okay, let's see. This is called once and that is it. But still, I am getting the same interrupt again and again. So something else is wrong. Let's check the camo logs. That's the best way. Let's remove camo and then run it. Run it. Give it enough cycles and we kill it. Oh, let's come to our camo log and see what the fuck is going on. Okay, this is where the repetition is happening. So let's go to the top of this repetition. Looks like there are some operations that are not repeated. Probably that's just the print message. I guess somewhere after this is where we just start doing the same thing again and again. So let's just go behind this line and see what was happening here. And every time we get IRQ fired, that's why I'm still wondering how is that possible. Okay, this is a good start. Let's just see what this is and then we will think about where we are. Okay, where's my VA? VA fucking broke. Okay, VA is just not working inside that file. Probably because the buffer size is too fucking big or something like that. It simply does not seem to be interested in working. Fuck me. Let's see. Okay. 800 123 1328. Okay, that's somewhere inside find free. I think I'm just going to search for. Oh, fuck me. Fucking piece of junk. Let's see, I don't know. Let's put PC. We would get all the PCs. Okay, this is how we are going back to the same things again and again. So we have 9.4 here. wait run camo bash builds kill it. Now take all PCs. Okay, we started here. We have this 9 F4 here. Let's see if we have another 9F4. We have the same here. What happened from here to here is the mystery. Select this and put, let's see if it test. Okay. Let's just see these addresses. Bash builds. Oh, what the fuck? Kernel. Now we can bash build and actually try these addresses. Let's try the first one. There's this. What is this address? It's UART. Maybe that's why we always have this UART code. Oh shit. Then we have to check. How can we check? Where did we start? We need some starting points. Is there any affair? Or about exception? Extension 5 and IRQ. We get an exception at that location. We kept getting exceptions. Exception written from EL1 to EL1 PC, taking IRQ at C1. See, so we kept getting exception. How to set time interrupts in ARM64. Let's see. Mhm. Mhm. In the interrupt handler, you must mask the interrupt so that, or disable timer. So we have to first of all, okay. Mm, First of all, inside the interrupt handler, where's my handler? Okay, so inside my handler, I have to disable the timer interrupts. That's why it's just keep on firing. Wait. We go into our interrupt. We can enable, we can read, set frequency. Okay, the current frequency is this current FRQ, but this is EL0. And CNT val. Timer value. This is the one that we set. CNT val. I don't have that instruction. Generic timer handlers. Okay, but the time does not report the timer. Usually each core has its set of timers. Okay. So EL1 physical timer is still EL0, and EL1 virtual timer is EL1 TB, and we are using a virtual timer. As it EL what CNTB. Yeah, we are using CNTB. It's okay. How do we enable and disable it? Ja, ja, ja. EL1 virtual timer is 27. Fine, that is what we are handling here. It's 27. That's good. Timer visualization. We went to that. I'm expecting some fucking codes. CNT, CR, enable, updation, etc. CNT, CR. Do we have that? We set it using CNT tval. We need assembly code. We don't have any package manager to. I think this guy should have explained it even better. CNTP. But he has used real timer. I only have virtual timer. Okay, we have defined all those stuff. Inside kmain, he has gid init. First of all, he has initted the GIC, and he has also set the core to 1 and clear timer IRQ and enable timer IRQ. CNTFRQEL0. He has read the value into x1 and then he has moved x1 into CNTP eval1. TP TV. He is using physical, so he has used P, but I'm using virtual, so nothing much is different. And then he has moved 1 into x0 and he has enabled it. So maybe, just maybe, have to first of all disable it when I'm trying to handle an interrupt. How do I disable that interrupt? How do I disable that interrupt? I don't know. I don't have any freaking clue. Shit. Timer. Handler. And arm. Okay. We have to disable it. Okay, how do I disable it? Wait a... I did have another example. Another example here. Here, what do? We do the same freaking thing. We have the scheduler. K-main. We schedule, set current, and inside handlers, time. Here, I think it's the same thing. Listen for interrupt in CPU 1. Did not do anything much. I get that. I acknowledge the one. Get the ID. And I set it. I set the timer. Acknowledge it. Send it back. Maybe I was wrong at that time. Oh no. Not sure. Here, when we get into this, let's enable this. Timer IRQ handler. And this is just going to probably disable the interrupt. until one of the iMask is set to 1, which masks the interrupt. Our enable is cleared, which disables the timer. Tval or cval is written, so the firing condition is no longer met. Okay. So we have to do is disable, just write disable shift at 0, and then inside this, let's call it let's disable oh shit. Okay, now we are stuck. Where are we stuck? I guess we are supposed to be stuck. Because we are not still switching the tables between two tasks. Because I was expecting to debug that case today. I didn't know we have this case. Let's just run it one more time. Okay, this is the first error. And it's 4F. What's that error? I've seen it. Yeah, this is expected because we were in EL0 and we tried to reach a kernel address, and that's why we got, I guess, access denied error. What the fuck? What's the exception? Taken from lower eval. Permission fault is not access is not permitted. Yeah, you are running EL1 code in a kernel stack. That's true. Issues that if you, I guess right now the at least the um, tasks are switching, so let's just confirm that and think about the actual, because currently what's the issues that we got a timer interrupt and we went back to the actual user process, and inside user process we tried to access a memory that's kernel FFFF. So from EL0 we are not supposed to access that. That's the error that I guess we can fix later. Let's just confirm if this works, because we don't have to do anything with these stuff. Let's just say, let's fix this and let's fix all of this. Yeah, let's just see if we are coming back here. And here. Enable it. Oh, fucking, where's that timer? Inline that. As soon as we do that, we are simply always having it enabled. And in that case, let's just check one more thing. There is inside timer. Actually, I should be calling enable or set. I should be calling set CNTV, not enable CNTV. I think, let's see, it should have already called it. Here I'm only getting we got one timer interrupt and we came here and we are still always running the kernel code. And I'm not satisfied. It does not seem to be working as I want it. We have to call read once and then divide it. If I do this, I always get this fired. Oh no. I have to disable it, update the timer. Or as per the condition, every time firing condition is no longer met. So even if we write to it, it should again try to fire, wait for some time. Maybe that's where something is going wrong. Maybe we are not writing it at all. I'm not sure. Currently, what's the behavior is that if I disable the timer just stops firing. is not what we want. We still want it to fire. So we enable it. We enable it with the value in it. And the value is maybe my set and has some issues. My timer interrupt is fired. It's getting fired. Time. Normal code that is in EL1 is never able to progress. This is the issue. Let's see. It's one shot. When it reaches 0, what do you mean? I am enabling it. So we rearm it. And then we enable it. Oh, so this is just saying this fact because I just copied one part of code, so that does not know that I am already refiring it, because every time I'm every time I get into that schedule.tick, I am setting something that is setting more value to it. Maybe I can print what the fuck am I setting there. That would be a good thing. Okay. UART puts. I have UART puts. No UART printf. Why is there no UART printf? UART printf is essential. No, fuck me. Why is there no UART printf? Setting back. My format specifier is L and rfreak. Okay, let's see. What the fuck happens? Wait. If I go here and if I enable this and I think I don't want to disable it, because as we see we just have to rewrite to it, so we don't want to enable it either. All we have to do is come here, acknowledge it, we update it again, and we go back. That's all we have to do. See, we have initially set it to 65.0 and then we never updated it. That's the whole fucking issue. Okay. Set CNT. I guess it's just going to set it and we can handle it. Wait. Okay, now it's working. Now we have interrupt and we have the kernel. Now it's switching back. So the actual issue was that we were not setting back the value, and for some reason I thought my schedule untick would set it, but for some reason my schedule untick never called this. That's why the value was always set to 0. Value was 0 if the interrupt is fired. If the value was 0 and after the first interrupt we never updated the value, that's why we fucked here. Okay, at least that's finished, so we can move on to the next issue. That would be accessing that there. Okay, I think it's fine. I'll work on that tomorrow then. Yeah. Thank you guys. Bye bye.